And we'll keep drifting, floating together through the mysteries. 100 dark matter mysteries, looping softly, endlessly through the night. Tonight we'll drift through. What if all the dark matter in the universe vanished? Every star, every planet, even you, would simply drift apart into nothing. Could dark matter be a ghost? The theory that it's actually hidden in dimensions we can't perceive, shadows of a universe beside our own. The bullet cluster, silent proof that made astronomers question everything they thought they knew about gravity. There's nothing you need to do now. Just let your body sink. Heavier, heavier. Feel the mattress holding you. Every muscle softening. Your heartbeat slowing. Thump, thump. Matching the rhythm of space itself. Shoulders melting down. Jaw releasing. Each breath pulling you deeper, deeper into the calm, the quiet, the dark. If this helps you rest, tap subscribe and hit like so others can find this calm too. But only if your eyes are still open, otherwise just drift. Now, let's drift into dark matter. The universe you see, the one you touch, the stars burning bright above, all of it, every atom in your body, every photon of light, makes up less than 5% of everything that exists. 5%, the rest, the vast majority, 85% of all matter is invisible, untouchable, unknowable. Scientists call it dark matter, but it doesn't absorb light, doesn't emit light, doesn't reflect light. It's a shadow, holding galaxies together, bending space itself. And we drift through it, right now, as you lie here, breathing, softening. Close your eyes if they're still open, or let them grow heavy, so heavy. There's nothing to see anyways in this darkness, this comfortable, endless dark. In the 1930s, a Swiss astronomer named Fritz Zwicky looked at something called the Coma Cluster, a collection of galaxies spinning, orbiting one another. He measured their speeds, and something was wrong, deeply wrong. The galaxies were moving too fast, far too fast, by all the laws of gravity, by everything Newton taught us. They should have flown apart, scattered into the void, like leaves in a storm, but they didn't. Something invisible, something with immense mass, was holding them together. Zwicky called it dunkle Materie, dark matter. He was the first to glimpse the invisible architecture of the cosmos. Breathe in slowly. 2, 3, 4. Hold. Breathe out. 6, 7, 8. Feel yourself sinking deeper into the bed, into the universe, held by something you cannot see. Decades passed. The 1970s arrived, and a woman named Vera Rubin, patient, meticulous, studied the rotation of galaxies. She watched how stars orbit around galactic centers, expecting them to slow down the way planets do. The farther from the sun, they move more slowly, but the stars, they didn't slow. They moved at the same speed, whether close to the center or at the distant edges, spinning impossibly fast, held by mass that wasn't there, mass that couldn't be seen. Her measurements were precise, undeniable. The visible matter, the glowing stars, the luminous gas. It wasn't enough, not nearly enough. something invisible, wrapped around each galaxy, a dark halo, pulling, gripping, keeping everything from flying away into nothing. Your breathing is slower now, isn't it? Each exhale, a little longer, a little softer. You're drifting like those stars held in place by forces you cannot name. Light itself bends when it passes near something massive. This is what Einstein taught us. Gravity curves space, and light follows those curves. Astronomers noticed that light from distant galaxies sometimes appears in strange places, distorted, stretched, forming rings and arcs across the sky. Gravitational lensing, they call it. But when they calculated how much visible matter would be needed to bend light that much, the numbers didn't match. Again, the invisible mass, dark matter, bending space, shaping light, creating illusions, cosmic mirages, showing us that most of the universe is hidden, forever hidden. Thump, thump. Your heart is calm now, steady, each beat echoing through your chest, through your arms, your fingertips, your mostly empty space. Did you know the atoms in your body, separated by vast distances at their scale? You are mostly nothing, just like the universe. In 2006, astronomers observed something extraordinary. Two galaxy clusters had collided, smashed together, in a cosmic catastrophe called the Bullet Cluster. When they examined the aftermath, they found that the visible matter, the hot gas, had slowed down, friction, interaction, but something else, something massive, had passed right through, unimpeded, like ghosts. The dark matter halos from each cluster had sailed through each other, barely interacting at all. This was the proof, the direct evidence to that dark matter exists, separate from ordinary matter, invisible, untouchable, but undeniably real. Let your jaw go slack, your tongue resting, soft behind your teeth. Feel the weight of your head pressing into the pillow, all tension draining away like water, like light, slipping through the universe. The universe was once so small, so hot, so dense. In the first moments after the Big Bang, everything was plasma, particles and light, tangled together, inseparable. Then, the universe expanded, cooled, and light broke free. That ancient light still surrounds us, the cosmic microwave background, a whisper from the beginning. Scientists measured its tiny fluctuations, its patterns, and found the fingerprints of dark matter. In the early universe, dark matter clumped first, pulling ordinary matter into its gravitational wells, seeding the formation of galaxies, of stars, of everything. Without dark matter, the universe would be smooth, uniform, empty. We owe our existence to this invisible mass, this dark scaffold. Heavier, heavier, your arms, so heavy now, you couldn't lift them if you tried, but you won't try. There's no need, just rest, just sink. What is it? This dark matter. Scientists have theories, possibilities, whispers in the dark. One idea, weakly interacting massive particles, WIMPs. They would be heavy, but they wouldn't interact with ordinary matter except through gravity. trillions of them, passing through your body right now, this very second, unfelt, unnoticed, invisible messengers from the cosmos. Deep underground, in abandoned mines, scientists have built detectors, tanks of liquid xenon, of liquid argon, waiting, hoping to catch just one collision between a WIMP and a nucleus, a flash of light, a whisper of energy, proof. But so far, mostly silence. The dark matter, if it's there, remains elusive. Your eyelids, sealed now, soft curtains drawn across your vision. You're floating in darkness, real darkness, comfortable, safe. Another theory, the axion, a particle so light, so ghostly, predicted by quantum mechanics, oscillating, creating tiny fields throughout space. Scientists built devices called haloscopes, microwave cavities, tuned, listening for the faint conversion of axions into photons, a whisper at a specific frequency, like tuning a radio, searching through static for a signal from the invisible. The Large Hadron Collider, deep beneath the border of France and Switzerland, smashes particles together at nearly the speed of a light, recreating conditions from the early universe. Scientists hope that in these collisions, dark matter particles might appear, briefly, fleetingly, before vanishing into the invisible again. They look for missing energy, momentum that disappears, carried away by something that cannot be seen. Breathe. You don't have to think about breathing. Your body knows. In, out, automatic, perfect, like the universe, expanding, contracting, breathing in its own way. Above Earth, satellites watch, telescopes gaze. The Fermi Gamma Ray Space Telescope searches for high-energy light from the centers of galaxies. If dark matter particles collide, annihilate each other, they might produce gamma rays, a flash, a signature. Scientists scan the galactic center, dwarf galaxies, looking for excess radiation, anomalies. But the signals are ambiguous, tantalizing, but unclear. The dark matter keeps its secrets. Some scientists wondered perhaps dark matter isn't exotic particles at all. Perhaps it's just ordinary matter that doesn't shine. Brown dwarfs, failed stars, too small to burn, rogue planets, wandering between the stars, black holes, scattered through the galaxy. Machos, they called them, massive astrophysical compact halo objects. But surveys searched, using gravitational microlensing, watching for distant stars to briefly brighten as a dark object passes in front, and the surveys found not enough, nowhere near enough to explain the missing mass. The darkness is not ordinary. Your thoughts are slowing, becoming soft, fuzzy, like distant radio signals fading. Words losing meaning, just sound, vibrations washing over you. Dark matter might come in different temperatures. Metaphorically speaking, cold dark matter, particles moving slowly as clumping together, forming structure, the halos around galaxies. This is the favoured model, fitting most observations. but some suggest warm dark matter, particles with more speed, smoothing out the smallest structures, or hot dark matter, like neutrinos, nearly massless particles, streaming across the universe at almost the speed of light. But neutrinos, we've measured them. They're too light, too fast to be the dark matter. They're ghosts, but not the ghosts we're looking for. Between galaxies, dark matter forms filaments, threads, connecting everything, a cosmic web, like neural networks, like mycelium, the hidden structure underlying everything you see. Galaxies form where these filaments intersect, pooling, like dew on a spider's web. Simulations show it, computers tracing the invisible architecture, beautiful, intricate, the universe, a vast organism, and we, tiny cells, in one small corner. Thump, thump, slower now, your heart rate dropping as you descend or into deeper rest. Theta waves rolling through your brain, the edge of sleep, so close. Our own galaxy, the Milky Way, is embedded in a dark matter halo, a sphere, extending far beyond the visible stars, perhaps 10 times the diameter of the luminous disk. We live inside it, swimming through it. The sun orbits, not just around visible matter, but through this invisible ocean, and the dark matter pulls on the sun, on the earth, on you, gently, imperceptibly, shaping our journey through space and time. Could there be dark planets, dark stars, structures made entirely of dark matter, clumped together, condensed? Most theories say no, dark matter doesn't interact enough to form such structures, but perhaps, in rare pockets, under strange conditions, dark matter might clump, creating invisible worlds, drifting through space, unfelt, unseen, forever hidden from our eyes. We would never know. We could pass right through, let go of wondering, of trying to understand. The universe doesn't need your understanding, it simply is. Vast, mysterious, eternal, and you are here, breathing, existing, part of it all. Some wonder if dark matter affects time. General relativity tells us mass curves space and time. Could concentrations of dark matter create time dilation, pockets where time runs differently, imperceptibly faster or slower? We wouldn't notice, wouldn't feel it, but perhaps as we move through the dark matter halo, time shifts subtly around us. At the quantum level, fields fluctuate. The vacuum isn't empty, it seethes with virtual particles appearing and vanishing in fractions of a second. Some theories suggest dark matter could be excitations of unknown fields, quantum foam, solidified into particles we cannot detect. The universe, stranger than we imagine, stranger than we can imagine. What if we never find it? Never detect dark matter directly? What if it remains forever, just out of reach, a permanent mystery? Would that be so terrible? The universe, holding on to its secrets. We've named it, mapped its effects, but never touched it, never seen it. Perhaps some things should remain unknown, hidden, sacred. The invisible made visible might lose its magic. Your body is so heavy now, merging with the bed, with the earth. You couldn't move, even if you wanted to, but you don't want to. This heaviness is peace, is surrender, is perfect. The core cusp problem. Puzzle scientists, computer simulations predict that dark matter should be densest at the centers of galaxies, forming sharp peaks, cusps. But observations show something gentler, smoother cores, the dark matter, more spread out than expected. Why? Does dark matter interact with itself? Just a little. Self-interacting dark matter. Particles that collide, rarely, scattering, softening the density. It's possible. Plausible. The experiments continue. The simulations refine. And there's another puzzle, the missing satellites problem. Simulations predict that large galaxies like the Milky Way should have hundreds of small dwarf galaxies orbiting them, but we only see a few dozen. Where are the rest? Were they never formed, torn apart by tidal forces, or is our understanding of dark matter incomplete? Perhaps warm dark matter, suppressing the formation of the smallest structures. Perhaps the universe is trying to tell us something we haven't learned to hear. Breathe in the dark. Breathe out your thoughts. Nothing left but this moment, this softness, this quiet. Some large dark matter clumps. Subhalos should be massive enough to have stars, galaxies of their own, but they don't. We see the gravitational effects, but no light, no stars. This is called the too big to fail problem. Why did star formation fail? In these halos, is dark matter behaving differently than we think? Or is star formation more fragile, more temperamental than our models suggest? The universe, full of puzzles, wrapped in darkness. Dwarf galaxy around Andromeda, around the Milky Way, orbit in strange patterns, planes, almost flat disks, rather than random orbits, scattered in all directions. The plane of satellites problem, another mystery. Did they form together from ancient tidal streams, or does this reveal something fundamental about dark matter, about gravity, about how structure form in the cosmos? We watch, we measure, we wonder. Your breath barely a whisper now, shallow, slow, perfect. The body's wisdom taking over, guiding you down, deeper into the well of sleep. What if dark matter has its own forces, its own interactions, a hidden sector, particles we've never imagined, dark photons, carriers of a dark electromagnetic force, dark matter atoms, complex, structured, a shadow universe overlapping our own, never touching, never interacting except through gravity. Two realities, sharing the same space, unaware of each other. You, right now, could be passing through a dark matter planet and never know. Or perhaps dark matter is ultralight, almost massless, fuzzy dark matter, particles with wavelengths the size of galaxies, quantum mechanics on cosmic scales. These particles would interfere, like waves, creating patterns, smoothing out the smallest structures, solving some of the puzzles that cold dark matter cannot. It's beautiful. The idea that the universe, at its largest, still dances to quantum tunes. Thump, thump. Your heart, so slow, so steady. You're almost there, almost asleep. Don't fight it. Don't hold on. Just let go. Some theories propose dark matter as a superfluid, a Bose-Einstein condensate, all the particles acting as one, a single quantum state spread across the entire galaxy, flowing without friction, behaving strangely at galactic cores. This could explain the core cusp problem, the rotation curves, a superfluid, dark and cold, permeating everything. Why is there dark matter at all in the early universe? Particles and antiparticles should have annihilated, leaving only light, but asymmetric dark matter theories suggest a tiny imbalance, more dark matter particles than antiparticles, just like ordinary matter, a cosmic coincidence or a deep connection between the visible and the invisible. Some dark matter particles might be super heavy, wimpzillas, created not through thermal processes, but through violent events in the early universe, phase transitions, topological defects, each particle incredibly massive, rare, passing through Earth, maybe once per century. We wouldn't build a detector large enough to catch them. They remain hypothetical, extreme, impossible to test. Your mind is drifting now, fragments of thoughts, dissolving like mist. The boundary between waking and sleeping, so thin, so permeable. You're crossing without noticing. Scientists use atomic clocks, the most precise instruments humanity has ever built, listening for tiny oscillations. If ultralight dark matter exists, its field would oscillate, causing fundamental constants to shift minutely. The atomic clocks would notice ticking differently. These experiments run continuously, searching for whispers in the fabric of space-time itself. Deep in laboratories, haloscopes hum, their microwave cavities tuned to specific frequencies. If an axion passes through, in the presence of a strong magnetic field, it might convert into a photon, a signal, faint but detectable. The ADMX experiment and others scan slowly through possible axion masses. It takes years, decades, patience, the virtue of those who seek the invisible. Pulsars, rapidly spinning neutron stars, emit radio pulses with extraordinary regularity, better than any clock. If a clump of dark matter passed between us and a pulsar, its gravity would shift the arrival time of the pulses just slightly. Scientists monitor hundreds of pulses, watching for the telltale delays caused by invisible mass. So far, nothing conclusive, but the watch continues. Neutron stars, incredibly dense, might capture dark matter As dark matter particles pass through, a few might scatter, lose energy, become trapped. Over millions of years, dark matter accumulates at the neutron star's core, annihilating, releasing heat. The neutron star, warmer than it should be. Astronomers search for the thermal signatures, anomalies, excess heat, proof of the invisible dwelling within. You're floating now, untethered. The bed beneath you, almost gone. You are a thought, drifting through space, nothing more, nothing less. The cosmic web, filaments of dark matter threading through the void, form the scaffolding, the architecture of the entire universe. Galaxies cluster along these threads, like dew on silk. The voids between, nearly empty, vast. Dark matter flows from the voids toward the filaments, toward the nodes where galaxies gather. It's beautiful, this hidden structure, revealed only through computer simulations and gravitational lensing. The universe painted in shades we cannot see. Could dark matter be primordial black holes? Black holes formed in the first seconds after the Big Bang from density fluctuations, not from dying stars, but from the universe itself collapsing in tiny pockets. These black holes could range in size, from microscopic to thousands of solar masses, but gravitational wave observations, microlensing surveys have constrained the possibilities. Most mass ranges have been ruled out. A few windows remain, but they're narrow. Black holes probably aren't the answer, but the search continues. At the center of our galaxy, the Milky Way's core, dark matter should be incredibly concentrated. If dark matter particles can annihilate, the galactic center would glow with gamma rays. Scientists detected an excess of gamma rays from that region. Could it be dark matter, or pulsars, or cosmic rays? The debate continues. The signal is there, but its meaning remains ambiguous, shrouded, like everything else, about the invisible mass. Thump, thump. You're barely here anymore. A whisper of consciousness, fading, soon, only dreams. The very first stars, population 3 stars and formed in the early universe, inside dark matter halos. These halos pulled in primordial hydrogen and helium, compressing them until fusion ignited. Without dark matter, those first stars might never have formed, and without them, no heavier elements, no planets, no life. We exist because dark matter built the cradle for the first light. In the early universe, phase transitions occurred. The fundamental forces separated, symmetries broke. During these transitions, dark matter might have been created, produced in vast quantities, freeze-out mechanisms where particles fell out of equilibrium, no longer annihilating fast enough, freeze-in mechanisms where particles were produced slowly, never reaching equilibrium. These are the birth stories of the invisible, theories written in mathematics, hoping to glimpse the moment darkness became substantial. Some dark matter might decay, slowly, over billions of years, releasing particles and cosmic rays, photons, creating excesses in the cosmic ray spectrum. Scientists analyze the data from space telescopes, looking for unexplained spikes, bumps in the energy distribution, hints of dark matter dying, transforming into something we can detect. But cosmic rays are messy, sources are uncertain, the signals ambiguous, dark matter influenced. The epoch of reionization, when the first stars ionize the hydrogen gas, filling the universe. The dark matter's gravitational pull determined where and when stars formed. Its distribution shaped the history of light returning to the cosmos. We detect this through the 21 centimeter line, radio waves from neutral hydrogen, mapping the early universe, dark matter's fingerprints in the radio sky. Your breathing, almost imperceptible, the rise and fall of your chest, so gentle, so slow, you're dissolving into the darkness, becoming one with the void. The early universe had sound waves, pressure waves in the plasma. These waves left imprints, dark acoustic oscillations, patterns in how dark matter clumps. These patterns propagate forward through time, influencing galaxy clustering. Today, scientists measure the distances between galaxies, finding echoes of those ancient sounds, vibrations from the beginning, still resonating. The Lyman Alpha Forest, absorption lines in the spectra of distant quasars, each line created by hydrogen gas along the line of sight, the distribution of this gas shaped by dark matter's gravity. By studying these forests, scientists probe the distribution of dark matter on small scales in the early universe. Its delicate work, interpreting shadows cast by the invisible. Gravitational microlensing surveys search for dark objects passing in front of stars. The star brightens briefly as the object's gravity bends and focuses. The star's light, surveys monitored millions of stars looking for macos, brown dwarfs, black holes, but they found not enough, far too few to account for dark matter. Another path closed off, another possibility eliminated. The process of science narrowing down the infinite to the possible. Dwarf spheroidal galaxies, small, faint, orbit the Milky Way. They contain almost no gas, no young stars, just old stars and vast amounts of dark matter, perfect laboratories for dark matter searches. Their simplicity makes them clean targets. If dark matter annihilates, dwarf galaxies should glow faintly in gamma rays. Scientists point telescopes at these dwarfs, searching for that glow. So far, nothing definitive, but absence is also information. The limits tighten, the parameter space shrinks. Weak gravitational lensing, the distortion of distant galaxy by intervening mass, allows scientists to map dark matter across vast regions, creating maps of the invisible, showing where it clumps, where it's sparse. These surveys cover significant fractions of the sky, revealing the cosmic web in exquisite detail. The universe's skeleton laid bare through light, bent by darkness. You're gone now, Aren't you asleep, finally, deeply, peacefully? But the voice continues, a lullaby for the unconscious, guiding you through dreams, through the mysteries. Galaxy clusters sometimes collide like the bullet cluster, but more subtle. Each merger an experiment where dark matter and ordinary matter, separate, behave differently. By studying many mergers, scientists constrain how dark matter interacts with itself. Does it scatter? Does it pass through unimpeded? The evidence suggests mostly it passes through, but perhaps with rare interactions, the picture slowly sharpening. Theoretical physicists explore hidden valleys, extra dimensions, landscapes of possibilities where dark matter might hide. Particles living in sectors completely disconnected from ours except through gravity. These theories, mathematical, beautiful, untestable, unless we're clever, finding indirect ways to probe the hidden. Some experiments search for dark matter baryon scattering, direct interactions between dark matter and ordinary nuclei. The rates would be low, but not zero. Hope remains. Mirror matter theories propose a twin universe. Every particle in our universe has a mirror partner in the twin. Mirror electrons, mirror protons, forming mirror atoms, mirror galaxies, interacting with us only through gravity. Our dark matter could be their ordinary matter, and vice versa. A poetic symmetry, two realities, reflecting, never touching. Your dreams are beginning, images flickering, nonsensical, beautiful. The brain, sorting memories, processing, creating. You drift through landscapes that don't exist, meeting people who aren't real. This is your universe now, stranger than dark matter, more mysterious, unique to you. Dark matter affects how cosmic structure grows as the universe expands. Over dense regions grow more over dense, under dense regions become more empty. Dark matter's gravity amplifies these differences. Without it, galaxies would be smaller, fewer, weaker. The universe would look nothing like it does. Dark matter isn't just invisible mass, it's the architect of everything you've ever seen. Perhaps in our solar neighborhood, there are dark matter mini halos, small clumps flying through space, relics of the early universe. They would pass through occasionally. If one passed through Earth, it might be detectable, a brief increase in direct detection experiments. But space is vast. These events, rare. We watch, we wait, hoping for a fleeting encounter with the invisible. Earth moves through the galaxy, through the dark matter halo at hundreds of kilometers per second. This creates a dark matter wind blowing past us. Dark matter streams, coherent flows from ancient mergers, from tidal disruptions. Sometimes we pass through them. The detection rate in underground experiments should modulate annually as Earth's orbit changes our velocity relative to the wind. The Dharma Libra experiment claims to see this modulation, but others do not confirm, the mystery deepens. Thump. Thump. The heartbeat of the universe, your heartbeat, indistinguishable now. You are the cosmos is you. Boundaries dissolved. Gravitational waves, ripples in space-time, detected by LIGO and Virgo, mostly come from merging black holes. But could dark matter produce gravitational waves? If dark matter has interactions, ultralight fields, they might create signals, continuous waves, or bursts. Scientists search through gravitational wave data for unexpected patterns. So far, only black holes and neutron stars, but the search expands. New detectors come online, listening to the vibrations of space-time itself. Black holes grow by consuming matter, stars, gas, anything nearby. But dark matter also falls in, adding to the black hole's mass at the centers of galaxies, supermassive black holes, surrounded by dense, dark matter cusps. The black holes feed, slowly but steadily, on the invisible, growing larger. Some of a black hole's mass might be dark matter, indistinguishable from ordinary matter. Once inside the event horizon, around supermassive black holes, dark matter orbits, accumulates, forms dense spikes. These spikes could produce annihilation signals, strong gamma rays from the very centers of galaxies. But the environments are complicated. Many processes produce gamma rays, disentangling them difficult. The search continues amid the chaos. Exoplanets, thousands of them, orbiting distant stars. Could they capture dark matter, like neutron stars, but slower, less efficient? Still, over billions of years, dark matter accumulates, annihilates, releases heat. The planet, warmer than expected, or the star, its interior heated by dark matter annihilation. Subtle effects, perhaps detectable with precise measurements. Another way to seek the invisible. In our own galaxy, the Milky Way, stars move in patterns, their velocities, their orbits, influenced by all the mass around them, visible and invisible. By measuring hundreds of thousands of stars, their precise motions, scientists can map the dark matter distribution, the halo's shape, whether it's spherical or flattened, lumpy or smooth. The stars, traces of the invisible ocean in which they swim. Cosmic voids, the vast empty regions between galaxy filaments, are not entirely empty. Dark matter exists there too, just less of it. But even that sparse dark matter affects how voids expand, how galaxies, at void edges, move. Studying voids complement studying clusters, two sides of the same coin. The universe's structure, both density and emptiness, shaped by the unseen. Axion-like particles, cousins of the axion, might interact with photons. Experiments shine intense laser light through magnetic fields. If axion-like particles exist, a few photons might convert, producing a faint signal on the other side of a barrier. That should be opaque, shining light through walls by borrowing the invisible these experiments exquisitely sensitive, searching for the faintest whisper of new physics. Some theories propose dark electron, dark protons, an entire periodic table of dark elements forming dark atom, dark molecules, maybe even dark chemistry, dark biology, a shadow biosphere, completely invisible, living in the same space, unaware of us as we are of them. It's speculation, wild perhaps, but the universe has surprised us before. Could there be dark plasma, electric and magnetic fields in the dark sector, dark matter particles with charge under dark forces interacting in complex ways, forming structures, flows, perhaps even dark lightning, dark weather, on dark planets we'll never see. The imagination runs wild, but mathematics constrains. Most models keep dark matter simple, non-interacting. It fits better with what we observe. You're deep now in the delta waves, dreamless sleep, the deepest rest, healing, restoring, the brain, flushing toxins, consolidating memories, your body repairing at the cellular level. This is what you needed, this peace. Dark matter and dark energy, both invisible, both mysterious, but different. Dark matter clumps, pulls things together. Dark energy pushes, expanding space itself. They might interact. Some theories suggest dark energy could decay into dark matter, or dark matter into dark energy, changing the balance over cosmic time, affecting the ultimate fate of the universe. Will expansion continue forever? Will it accelerate endlessly? Or will some interaction between the dark components change everything? Only time will tell. Deep time, billions of years, the universe unfolding its story slowly. In a dying universe, trillions of years from now, stars will fade, galaxies will drift apart, accelerated by dark energy into the endless dark. But dark matter will remain, clumped in halos around the last embers of dying galaxies. Long after light has ceased, dark matter endures, the final monument to a universe that once was bright. Some physicists wonder if our universe is one of many, a multiverse, infinite variations, with different laws, different constants. In some universes, dark matter doesn't exist. In others, it's even more abundant, perhaps only in universes like ours. With just the right amount, can galaxies form, can life arise? Anthropic reasoning. We exist, therefore. The universe must be incapable of producing us. Dark matter, part of that delicate balance. Without it, no stars, no planets, no you. The invisible cosmos is more vast than the visible. What we see, stars and galaxy, just foam on a dark ocean. We've mapped that ocean through its effects, its gravity, its structure, but we've never touched it, never captured a single particle. It's humbling, this ignorance. After centuries of science, the universe still hides most of itself from our eyes. Scientists around the world compete and collaborate, building detectors, designing experiments, publishing results, debating interpretations. It's a quiet race, no finish line in sight, but the journey, the search itself, drives them forward. The hope that one day, maybe tomorrow, maybe in 100 years, a signal will appear, undeniable, clear, and we'll finally know what is the dark that holds us together. We visualize the invisible through simulations, through models. We create images, maps of dark matter, false colors, representations, but they're not real, not photographs, just our best guesses, interpretations of indirect evidence. We make the invisible visible in our minds, but it remains forever beyond our senses, a universe built on shadows, on faith in mathematics, in reason. Breathe. The darkness around you, outside and inside, the same. All is dark, all is mystery. You're part of it. The invisible, holding you as you sleep. Perhaps that's the beauty. We don't need to see to know something is real. Dark matter taught us that. Reality extends beyond our perception, beyond our senses. There's wisdom in that, in accepting that we are small, limited, yet part of something incomprehensibly vast. Your body completely relaxed now, every muscle loose, soft, your face smooth, all the tiny muscles around your eyes, your mouth released. You are perfectly still, like space itself, in the voids, between galaxies, calm, empty, at peace. The search continues, in laboratories, deep underground, away from cosmic rays that would drown out any signal. Tanks of xenon, of argon, cooled to extreme temperatures, waiting in darkness, in silence, for years. Occasionally, a particle strikes, but always something expected. Background radiation, never the elusive dark matter. The detectors grow, larger, more sensitive, each generation pushing deeper into the unknown, hoping that somewhere in the vast parameter space, dark matter is waiting to reveal itself. Thump, thump. So slow now, your heart barely laboring, efficient, perfect, the body's wisdom, knowing exactly what you need, less, always less, as you descend into deeper rest. Some experiments search not in depth, but in breadth. Sky surveys, mapping billions of galaxies, measuring their shapes, their positions, looking for patterns, correlations, the subtle fingerprints of dark matter's gravity across cosmic scales. These surveys have names like poetry: Sloan Digital Sky Survey, Dark Energy Survey, Legacy Survey of Space and Time, each one pushing further, seeing fainter, assembling piece by piece a map of the invisible. Next generation telescopes, soon to come online, you will see farther, more clearly. The James Webb Space Telescope, already operational, peers into the early universe, seeing the first galaxy forming in dark matter halos. Ground-based telescopes with enormous mirrors, adaptive optics, correcting for atmospheric blur, all of them tools to study what we cannot see, by examining what we can. Scientists dream of a grand unified theory, a framework that explains all the forces, all the particles, matter and antimatter, dark matter and dark energy, quantum mechanics and gravity, unified, one elegant equation, describing everything, string theory, loop quantum gravity, other mathematical landscapes, explored, but none yet proven, none yet complete, dark matter, a piece of the puzzle that doesn't quite fit, reminding us how much we don't know. Your mind, if it's aware at all, is barely a flicker. Most of you has shut down, gone offline. Only the essential systems, running, breathing, heartbeat, the autonomic, keeping you alive, everything else, silent. This is the deepest rest. Their bodies' chance to heal. Neutrinos, ghost particles, were once candidates for dark matter. They barely interacted with anything. Trillions pass through you every second, from the sun, from distant supernovae. But scientists measured their mass, incredibly tiny, too light to be dark matter. They contribute, but only a fraction of what's needed. Still, their existence proved something important. Invisible particles are real. If neutrinos exist, why not others? Heavier, stranger, sterile neutrinos, hypothetical cousins of ordinary neutrinos, wouldn't interact, even through the weak force, only gravity, making them perfect, dark matter candidates. Some experiments claimed hints, anomalies in decay rates, unexplained signals, but others couldn't reproduce them. The hints faded, became uncertain. Perhaps sterile neutrinos exist, but are not dark matter. Perhaps they don't exist at all. The universe, refusing to give easy answers. Indirect detection strategies look for products of dark matter annihilation or decay, gamma rays, neutrinos, antimatter, anything that might signal dark matter destroying itself, converting from invisible to visible. Space telescopes, Antarctic detectors, balloon-borne experiments, all searching the sky for excess signals, anomalies, hope in the data. But the backgrounds are complex. The universe, full of other sources, pulsars, supernovae, active galaxies. Distinguishing signal from noise requires patience, statistics, years of observation. The mystery of dark matter connects to philosophy, to meaning. What does it say about our place in the cosmos? That most of reality is hidden from us, that our senses, our instruments, can only perceive a tiny fraction of what exists. Are we insignificant, or are we remarkable for understanding even that much, for inferring the invisible through mathematics, through reason? Humanity's greatest achievement might be knowing what we cannot see. Children ask, "What is dark matter made of?" And we answer, "We don't know." It's okay not to know. Science isn't about having all the answers. It's about asking questions, designing experiments, following evidence wherever it leads. Dark matter is a question. We're still learning how to ask properly. You're breathing, so shallow now, almost imperceptible. The rise and fall barely visible. This is perfect. This is exactly where you should be. Deep, so deep in sleep's embrace. Throughout history, humans looked up and wondered, what are the stars? What is our place? Each generation answered differently, each answer deeper than the last. Now we know the stars are suns, far away. We know the universe is vast, ancient, expanding, and we know most of it is invisible. Each answer reveals new mysteries, new questions. Perhaps that's the point, not to solve the universe, but to engage with it, to wonder endlessly. Fritz Zwicky died in 1974. Before dark matter became widely accepted, he was often right, decades ahead. His peers dismissed him, called him difficult, eccentric, but history vindicated him. Dark matter is real, the universe, held together by something we cannot see. He saw it first, through mathematics, through observation, through stubbornness. Sometimes the lone voice is correct. Vera Rubin, who died in 2016, never won the Nobel Prize. Despite her groundbreaking work on galaxy rotation curves, the evidence that convinced the world dark matter exists, recognition came late or not at all. But her legacy is secure. Every dark matter search, every detector, every simulation stands on foundations she helped build. Science is cumulative. Each generation building on the last. Slowly, we approach the truth. The experiments continue in mountains, underground, in space. Particle accelerators, telescopes, atomic clocks, all searching for the same thing, that first direct detection, the moment when dark matter stops being inference and becomes tangible, real, confirmed. That moment will come, perhaps in our lifetimes, perhaps not, but it will come. The universe eventually reveals its secrets to those patient enough to listen. You're so far away now, gone into depths where even dreams don't reach. Just the body, breathing, existing, the mind, quiet. This is healing. This is what you needed. Imagine a particle so weakly interacting that it could pass through a light year of solid lead without touching anything. That's dark matter. Trillions, quadrillions, passing through Earth, through you, every second. Unfelt, unnoticed, like ghosts, like thoughts, like the space between heartbeats, here and not here, existing in a way that defies our intuition. The cosmic web extends beyond what we can see. Filaments of dark matter connecting galaxy clusters across hundreds of millions of light years, the largest structures in the universe held together by the invisible. Everything connected, nothing truly isolated. You, lying in bed, are part of this web, gravity linking you to distant galaxies, the universe, a single organism, breathing, thinking, perhaps in ways we can't fathom. Thump, thump, the rhythm, eternal. Before you were born, after you're gone, the universe's heartbeat continues. Dark matter holding it together through all of time. Some wonder if consciousness itself might be connected to dark matter. Wild speculation, no evidence, but humans have always sought connections between the physical and the experiential. Perhaps dark matter is just matter, nothing more. Or perhaps the universe is stranger than we can imagine. Consciousness, arising from quantum fields, dark matter, woven into the fabric of thought. Probably not, but the question lingers like a dream upon waking. The amount of dark matter in our solar systems is minuscule. Its density in our neighbourhood incredibly low. About 1 proton mass per cubic centimetre, nearly nothing, yet integrated over galactic scales, over the volume of the Milky Way's halo. It adds up to more mass than all the stars combined. The universe is big, and even the sparsest substances become significant when multiplied by infinity. Your body temperature has dropped slightly, as it does in deep sleep, conserving energy, all systems in low power mode, the brain using less glucose, the muscles completely relaxed, not even the microtensions of waking life, just pure rest. Dark matter doesn't emit light, doesn't absorb light, doesn't reflect light. So how do we know where it is? Through gravity, its mass curves space, bends light, pulls on stars and gas. We map dark matter by mapping its effects, like mapping wind by watching leaves. We never see the wind, but we know it's there. Dark matter, the wind of the cosmos. In the early universe, as before stars, as before galaxies, as there's dark ages, after the Big Bang's light faded, before the first stars ignited, the universe was dark. Neutral hydrogen filled space, absorbing visible light, but dark matter was there, clumping, pulling hydrogen into the densest regions, setting the stage for the first light to return. Dark matter, the stagehands of creation. The 21 centimetre line is a radio emission from neutral hydrogen. By mapping this emission from the dark ages, scientists can see how dark matter shaped the universe before stars. It's challenging. The signals are faint, red-shifted, but radio telescope in quiet deserts, far from interference. Listen patiently, building maps of the invisible past. Galaxy clusters, the largest bound structures, contain thousands of galaxies, hot gas, and vast amounts of dark matter. The gas, so hot it emits X-rays. We see it glowing in X-ray telescopes, but the mass needed to hold that gas in place to keep the galaxies bound far exceeds what we see. Again, dark matter, the majority in every cluster, invisible, essential. Let your mind float away like a leaf on a dark river. No destination, no goal, just drifting, the current taking you wherever it will. Trust the darkness, trust the flow. When galaxy clusters collide, the process takes millions of years. Galaxies pass through, mostly empty space. They rarely collide. But the gas, the hot plasma, it interacts. Friction, drag. It slows down, stays behind. But dark matter passes through, like the galaxies, unimpeded. This separation, visible through lensing and X-ray observations, is the smoking gun, the proof that dark matter is not ordinary, it's something else, something invisible, something real. Physicists wonder if dark matter particles have antiparticles. If they do, and if they meet, they would annihilate, releasing energy, photons, perhaps gamma rays. This is the basis for indirect detection. But if dark matter is its own antiparticle, the annihilation rate would be different, the signals harder to detect. Or if dark matter is utterly stable, never decaying, never annihilating, we might never see any signal at all. It would just exist, silent, forever. Some galaxies, called ultra-diffuse galaxies, are extremely faint, spread out, almost invisible, but they rotate, as if they have mass, much more mass than their stars. They're almost entirely dark matter, barely any visible matter. Studying them helps scientists understand the relationship between dark matter and galaxy formation. When does dark matter gather stars? When does it remain dark and lonely, invisible in the night? The universe might be filled with dark matter galaxies, collections of dark matter with no stars, no light, completely invisible. We would never know. They could be everywhere, passing by, passing through. We'll never see them, never detect them, unless they happen to pass in front of a distant star, causing a brief gravitational lensing event, a flicker in the light, and then gone back into the invisible. Your heartbeat, your breath, are all that remain, the last anchors to waking life. Soon, even these will fade from your awareness, and you'll be completely gone into the depths of sleep. Dark matter might solve other mysteries beyond just galactic rotation and structure formation. Perhaps it explains the matter-antimatter asymmetry, why there's more matter-sen than antimatter. Perhaps it relates to the hierarchy problem, why gravity is so weak compared to other forces. Perhaps it's the key to quantum gravity, the bridge between the very small and the very large. One mystery could unlock many others. Or perhaps dark matter is simple and the other mysteries remain. Scientists are humble in the face of the unknown. They build detectors, they gather data, they propose theories, but they admit freely, we don't know. 3 words that drive science forward. We don't know yet, but we will. Keep searching, keep questioning, keep listening to the universe's whispers. The universe is patient. It's been here billions of years. It will be here billions more. Our experiments, our questions are fleeting, momentary, but meaningful. We are the universe, trying to understand itself, consciousness, arising from matter, dark and visible, looking inward, wondering, who am I? What am I made of? And finding that the answer is mostly mystery. Breathe. Just breathe. Nothing more, nothing less. This moment is perfect. You are perfect as you are here, now, in the darkness. Dark matter, invisible, ubiquitous, essential, mysterious, holding galaxies together, shaping the cosmos, bending light, bending space, and yet unseen, unfelt, unknown. We infer it, we map it, we name it, but we've never touched it. Perhaps we never will. Perhaps that's okay. Some things should remain mystery. Thump, thump. The sound of existence continuing, simple, eternal. You are here. The universe is here. Both mostly dark, both mysteriously alive. Experiments will continue for years, decades, centuries. Humanity's search for the invisible will persist because we are curious, because we wonder, because we need to know what we're made of, where we came from, where we're going. Dark matter is part of that story, an essential chapter still being written. The darkness around you and the darkness in space, the same. One darkness, encompassing everything. You, the Earth, the galaxy, all of it, held in dark matter's embrace, unseen, but ever present. Your consciousness, almost gone now, a flickering candle in the wind, soon to go out, and when it does, only peace remains, only rest, only the darkness, welcoming you home. Scientists sometimes joke that dark matter is humanity's most expensive game of hide and seek. We're seeking. The universe is hiding. Trillions of dollars, thousands of researchers, decades of work, and still we seek. But it's not a game. It's a quest for knowledge, for truth, for understanding our place in the cosmos. Perhaps dark matter will be discovered tomorrow, next year, or perhaps it will take 100 years, 1,000, or perhaps we'll never detect it directly and will forever only know it through its effects on the visible. Would that diminish it? Would that make it less real? No, reality doesn't depend on our ability to perceive it. You're asleep now, truly deeply asleep, but the voice continues, a whisper in the void, accompanying you through the long, quiet night. Every galaxy, every cluster, every structure we see exists because dark matter pulled it together. The universe is a collaboration between visible and invisible, between light and dark, neither sufficient on their own. Together they create everything. The cosmic microwave background, that ancient light, shows tiny fluctuations, temperature differences of 1 part in 100,000. These fluctuations grew over billions of years, amplified by gravity into galaxies, clusters, the cosmic web. Dark matter provided the gravitational seed for all of it. Without those seeds, the universe would be smooth, uniform, lifeless, empty. Dark matter is the reason you exist, the reason stars formed, planets coalesced, life arose, everything traces back to the invisible, the dark scaffolding of creation. We are children of darkness, made visible through the alchemy of stars. Thump, thump, slower still. Your body knows what it needs. Deep rest, deep healing, the darkness holding you, keeping you safe. The search for dark matter is really a search for ourselves, for our origins, for our context. We want to know what universe we inhabit, what it's made of, how it works. This curiosity defines us, makes us human. Even if we never find the answer, the search itself is worthwhile, noble, beautiful. Imagine if dark matter were suddenly visible, if we could see it with our eyes. The night sky would be transformed, glowing filaments connecting galaxies, halos around every star cluster, the cosmic web laid bare. It would be breathtaking, beyond comprehension, but it's hidden, and perhaps that's for the best. Some mysteries should remain to inspire wonder, to remind us of the limits of our perception. You are deep in the ocean of sleep, fathoms below the surface, where light doesn't reach, where sound doesn't penetrate, just darkness, silence, peace, the pressure of the deep holding you, suspended in perfect equilibrium. Scientists working on dark matter know they might never find it in their lifetimes, but they persist because the work matters, because contributing to human knowledge, even incrementally, is meaningful, because being part of this quest, this grand human endeavor, is its own reward. Dark matter teaches us humility. We thought we understood the universe, Newton's laws, Einstein's relativity, quantum mechanics. We thought we had it figured out. Then we discovered that most of the universe is made of something we know nothing about. It's humbling, healthy, a reminder that there's always more to learn, always deeper mysteries waiting. The universe doesn't owe us answers. It exists regardless of our understanding, but it offers clues, hints, patterns for those patient enough to look, careful enough to measure, bold enough to interpret. Dark matter is one such clue, leading us toward deeper truths about reality, about existence itself. Breathe the darkness, breathe the silence, breathe the peace. You are exactly where you need to be, safe, held, at rest. Thump, thump. The universe pulses with invisible energy, dark matter, dark energy, gravity, quantum fields, all of it vibrating, existing in ways we're only beginning to glimpse. You are part of this vibration, this cosmic symphony, playing in frequencies we cannot hear. In the end, dark matter might be surprisingly simple or shockingly complex. We don't know. Both possibilities remain open. The universe has surprised us before. It will surprise us again. That's what makes this beautiful, the unknown stretching before us, infinite, inviting. Your body has entered the deepest phase of sleep, delta waves rolling through your brain, every cell, regenerating, healing, restoring. This is why you're here, why you needed this. The dark, the quiet, the voice guiding you into peace. Some night in the future, perhaps a scientist will shout with excitement, "We found it, a signal, clear, unmistakable, dark matter detected." That moment will change everything, our understanding of physics, of cosmology, of our place in the cosmos. Or perhaps that moment will never come, and dark matter will remain forever, a beautiful mystery. Either way, the universe continues, indifferent, eternal. You are so far away now, gone into depths beyond reach, and that's perfect. That's exactly right. Sleep, deep sleep, is where you belong. Now, rest, heal, dream, or don't dream, just be in the darkness, in the silence, in the infinite mystery. Dark matter, invisible, essential, real, holding everything together, just as sleep holds you now in its gentle, unbreakable embrace. The galaxies turn slowly, majestically, held by dark matter's invisible hand. You turn in sleep, rolling over, shifting, held by the bed, the earth, gravity, both visible and dark, everything connected, everything held. Scientists will keep searching, experiments will continue, the quest for the invisible persists. But for now, for you, none of that matters. Now, there is only this moment, this darkness, this peace, this perfect, deep sleep. Thump. 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 The heartbeat fading into the background of consciousness. Soon, even this will disappear, and only the void remains. Dark, quiet, eternal, home. Dark matter is everywhere, in this room, passing through you, through the walls, through the earth, invisible, unnoticed. Always. It's been there, your whole life, before you. Born, after you're gone, a constant companion. You've never met. The universe is patient, kind. In its way, it holds you through dark matter's gravity, through the earth's embrace, through the bed's support, layers of holding, layers of care, from the cosmic to the intimate, all of it, keeping you safe as you sleep. Rest now, deep rest, let go of everything. The mysteries can wait, the universe can wait, science can wait. For now, just sleep, just darkness, just peace, perfect, complete peace. And when you wake, if you remember any of this, it will seem like a dream. Dark matter, mysteries on this cosmic web, all of it, dreamlike, distant, but it's real as your heartbeat, as your breath, as the darkness behind your closed eyes. The universe keeps turning, held fast by dark matter's unseen hand, and will keep drifting, floating together through the mysteries. 100 dark matter mysteries, looping softly, endlessly through the night, and we'll keep drifting, floating together through the mysteries. 100 dark matter mysteries, looping softly, endlessly through the night. Thump, thump. Your heart barely a whisper in the dark, the rhythm of existence continuing whether you're aware or not, life persisting in the depths of sleep. The universe has so many layers: quarks and leptons, atoms and molecules, stars and galaxies, and underneath it all, dark matter, the foundation upon which everything else is built. We live on the surface of a deep, dark ocean, never seeing the depths that support us. Primordial black holes, formed in the universe's first fraction of a second, could account for some dark matter. Tiny black holes, smaller than atoms, or massive ones, thousands of times heavier than the sun, scattered through the galaxy's halo, silent, invisible, occasionally bending light from distant stars, but surveys have constrained how many can exist. Most mass ranges excluded, only narrow windows remain. Perhaps a small fraction of dark matter, perhaps none. The question lingers. Your breathing, so soft now, like wind through distant trees, barely moving, barely there. The body, in its wisdom, taking exactly what it needs, no more, no less. Perfect efficiency, ultra-high energy cosmic rays sometimes strike Earth's atmosphere, particles with incredible energies from unknown sources. Could dark matter be accelerated somehow and produce these rays? Scientists analyze the cosmic ray spectrum, looking for anomalies, unexpected bumps at specific energies that might indicate dark matter decay or annihilation. The data is complex, full of backgrounds, but patterns emerge, slowly, ambiguously. The search continues in the centers of galaxies where dark matter is densest. Strange things might happen. Dark matter particles captured by the central, supermassive black hole, annihilating, releasing heat, energy. This could affect black hole growth, jet formation, the interplay between visible and invisible, at the heart of every galaxy, a cosmic dance. We're only beginning to understand. Let yourself sink deeper, if you can go deeper than where you are. Let go even more fully into the abyss, the comfortable, safe, warm abyss of sleep. Dark matter stream, relics of ancient galactic mergers, flow through our neighborhood like rivers. In the night, the Milky Way has consumed smaller galaxies over billions of years. Each merger leaves behind streams of stars and dark matter moving together through space. We pass through these streams, our motion through the galaxy, sometimes aligned, sometimes opposed, creating annual modulation in potential detection rates. Thump, thump. The sound fading now into background like distant thunder, barely noticed, barely felt. You are almost completely gone. The Dama Lebra experiment, deep underground in Italy, claims to detect annual modulation, a signal rising and falling with the seasons as Earth's motion through the dark matter halo changes, but other experiments using different methods see nothing, no confirmation. The controversy continues. Is Dama seeing dark matter or something else? Background fluctuations, systematic effects, unknown, the mystery within the mystery. Axion dark matter, if it exists, would form a condensate, a coherent field, oscillating at a frequency related to its mass. These oscillations could affect fundamental constants, the fine structure constant, the electron mass. Atomic clocks, comparing different types, might detect tiny oscillations in their rates, signals of the invisible field permeating space. Experiments run continuously for years, accumulating data, searching for patterns in the noise. You are a pattern in the noise of the universe, a brief arrangement of atoms, conscious for a moment, then returning to the cosmic mix. But while you're here, you experience this darkness, this peace, this mystery, unique, unrepeatable, precious. Dark sectors, hidden valleys in the landscape of particle physics, entire families of particles interacting only with each other and with us through gravity, a shadow universe occupying the same space but invisible, intangible. This is where dark matter might reside, in a parallel physics, disconnected yet overlapping. Our reality, mirror matter, takes this further, suggesting perfect symmetry. Every particle has a mirror twin, mirror electrons, mirror protons, forming mirror atoms, mirror stars, perhaps even mirror life, all of it invisible to us, except through gravity. Our dark matter could be their ordinary matter, a beautiful symmetry, unproven but elegant, the universe doubled, hidden, forever apart. Breathe in the void, breathe out yourself, dissolving the boundary between you and the universe, thinning. Soon there will be no difference, just existence, pure, simple, one. Dark matter and dark energy, both named for our ignorance, both invisible but different. Dark energy pushes space apart, accelerating the universe's expansion. Dark matter pulls, clumping, forming structure. They might interact. Some theories suggest dark energy could decay into dark matter, or vice versa, changing the balance over cosmic time, affecting the universe's fate. Will it expand forever? Will it collapse? Will something else happen? Only time will tell. In the far future, trillions of years from now, stars will die, galaxies will fade, dark energy will push everything apart until each galaxy is alone, isolated in an empty void, but dark matter will remain, holding each galaxy together, against the pull of dark energy. Long after light has ceased, dark matter endures the last structure in a dying universe. Thump, thump, barely perceptible. Your heart knows its job, doesn't need your attention, doesn't want it, just does what it does, eternal, reliable, until one day it stops. But not tonight. Tonight it beats, soft and slow, keeping you alive in the darkness. Multiverse theories suggest our universe is one of many, perhaps infinite, each with different physical laws, different constants. In some, dark matter doesn't exist. In others, it's everything. Our universe has just enough to form galaxies, to create stars, to allow life. Is this coincidence or selection? Do we live here because only here can life? Ask the question. The anthropic principle, controversial, unfalsifiable, but compelling in its logic. You don't need to understand any of this. Understanding is for waking minds. Now, there is only sensation, softness, weight, warmth, darkness, the mind shut down, the body at rest, perfect balance. Scientists visualize dark matter through false color images, computer simulations, artistic representations, blues and purples, flowing filaments, glowing halos, but these are inventions, interpretations. Dark matter has no color, no appearance. It's invisible. By definition, we make it visible in our minds, to comprehend it, to share it, to make it less frightening, more familiar, but it remains, forever unseen, a concept, not a perception. The invisible cosmos, vaster than the visible, by far what we see with telescopes, with eyes, is foam on a dark ocean, bubbles on the surface of something incomprehensibly deep. We've mapped that surface, measured the foam, but the depths remain unknown, unknowable. Perhaps this should be comforting, not frightening. We are part of something much larger than ourselves, larger than we can comprehend. The universe doesn't need our understanding. It simply exists, vast, mysterious, eternal, and we are here for a moment, witnessing, experiencing part of it. The heartbeat of the cosmos, your heartbeat, no difference. All matter, all energy, connected through forces, visible and invisible. You are the universe, experiencing itself through your particular arrangement of atoms. The quest for dark matter will continue long after we're gone. Future generations, with better tools, better theories, will keep searching. Perhaps they'll find it, perhaps they won't. But the search, the curiosity, the wonder, that persists, that defines us, that makes us human. Even if dark matter is never detected directly, it's still real. We know from its effects, from the rotation of galaxies, from gravitational lensing, from the bullet cluster, from the cosmic microwave background. The evidence is overwhelming. Dark matter exists, even if it remains forever beyond our grasp. Your consciousness is gone now, completely. Only the autonomic functions remain: breathing, heartbeat, temperature regulation, the brain, performing maintenance, consolidating memories, flushing toxins, the body, healing. This is why sleep exists, not just rest, but restoration, essential for life. Some mysteries are not meant to be solved, at least not yet. Perhaps dark matter is one of them, a permanent question mark in our understanding of the cosmos, and maybe that's beautiful, a reminder of how much we don't know, how much there is still to discover. The universe holding its secrets close, sharing them slowly, if at all. Dark matter could be so many things: WIMPs, axions, sterile neutrinos, primordial black holes, hidden sector particles, ultralight bosons, super heavy relics, self-interacting particles, or something we haven't imagined yet. The parameter space is vast, most of it unexplored. Each experiment rules out a small region. Slowly, the possibilities narrow, but vast spaces remain. Breathe. Just breathe. Nothing else matters. Nothing else exists. Just this moment, this breath, this darkness, this peace. Perfect, complete, infinite. The universe is patient. It's been expanding for 13.8 billion years. It will continue for trillions more. Our questions, our experiments are fleeting, brief candles in cosmic night, but meaningful to us. And perhaps that's enough. We don't need to understand everything, just to wonder, just to try, just to be part of the quest. Thump, thump. So faint now you wouldn't hear it if you were awake, but you're not. You're deeper than deep, beyond dreams, beyond thought, beyond self, just existence. Pure, simple being. Dark matter teaches us that reality extends beyond our senses, beyond our instruments. Even we've learned to infer the invisible through mathematics, through observation, through reason. This is humanity's greatest achievement, not seeing, but understanding what cannot be seen. Children will grow up in a universe where dark matter is common knowledge, part of their understanding. From the start, they won't remember a time when we didn't know about the invisible mass holding galaxies together. For them, it will be obvious, normal, the way evolution is obvious to us, though it was revolutionary once. But the mystery will remain until dark matter is detected directly, until we know what it's made of, how it behaves, whether it interacts with itself, with us, beyond gravity. So many questions still unanswered, so many experiments yet to run, so much still to learn. Your body has entered the deepest rest, maximum recovery, happening now at the cellular level. DNA repair, protein synthesis, memory consolidation, hormone regulation, all of it proceeding automatically, perfectly. The body's wisdom, ancient, evolved, over billions of years, knowing exactly what to do when given permission to rest. Dark matter might be the key to quantum gravity, the theory that unites general relativity with quantum mechanics. Perhaps understanding dark matter's properties will reveal how gravity works at the quantum level. Perhaps it's a clue to string theory, to loop quantum gravity to whatever framework finally explains everything. Or perhaps it's unrelated, a separate mystery. Either way, the quest continues. Some scientists dedicate their lives to this search, building detectors, analysing data, publishing papers, never seeing a positive result, never detecting dark matter directly. Yet they continue because the work matters, because contributing to human knowledge, even through negative results, even through ruling out possibilities, is valuable, is meaningful, is enough. The darkness around you is total, complete, safe. This is where you belong right now, in this moment, nowhere else, nothing else, just here, just now, just being in the dark. The rhythm, so slow, so soft, life at its quietest, least demanding, most peaceful. This is the gift of sleep, of darkness, of letting go completely. Dark matter, invisible, mysterious, essential, real, has shaped the universe, has created the conditions for stars, for planets, for you. Without it, nothing would exist as it does. We are children of the invisible, offspring of darkness, made visible through chemistry, through biology, through consciousness, but rooted forever in the dark. The cosmic web extends infinitely in all directions, filaments of dark matter connecting everything to everything else. You are part of this web, connected through gravity, through the atoms in your body, formed in stars, long dead, through your thoughts, your dreams, your existence, part of the universe's self-awareness. Scientists will keep searching in underground labs, in particle accelerators, in space telescopes, using pulsars, atomic clocks, gravitational waves, every method, every approach, hoping that one day the invisible becomes visible, that dark matter reveals itself, that the mystery is solved. But even if it never happens, the search was worthwhile. The journey itself is the destination. Your mind is completely quiet. No thoughts, no dreams, just the void, consciousness, paused, reset, the brain, resting in darkness, as deep as the space between galaxies, as quiet as the vacuum of space, perfect stillness. Thump, 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 each beat softer than the last, or maybe they're the same, and you're just farther away, descending into depths where sound doesn't reach, where light doesn't penetrate, where only silence remains. The universe keeps its secrets closely. Dark matter is just one of many. Dark energy, black holes, quantum mechanics, consciousness itself, mysteries, layered upon mysteries. The more we learn, the more we realize how little we know. This is the human condition, seeking, always seeking, never quite finding, but growing, evolving, understanding more with each generation. Perhaps in 100 years, we'll look back and smile at how little we knew about dark matter, how our theories were crude, our experiments primitive, the way we look back now at early scientists thinking atoms were indivisible, that space was filled with ether. Each generation thinks it knows, then the next proves them wrong or incomplete. This is progress. This is science. This is beautiful. Breathe in, darkness. Breathe out, light. The cycle continues forever, whether you're aware or not. The universe breathing through you, you are an aperture through which the cosmos experiences itself for a moment, brief, precious, unique. Dark matter will outlast humanity, will outlast the sun, will outlast all the stars in the night sky. It will remain after the last galaxy fades, after the universe grows cold and dark and empty. Dark matter will still be there, invisible, silent, eternal, the final witness to everything that was. And in that far future, perhaps some new form of intelligence will wonder about dark matter, will build their own experiments, will search. As we search, we'll wonder as we wonder. The quest never ending, the mystery never solved. Or perhaps one day someone, somewhere will find it, will understand, will know what can only guess at. But that day is not today. Today, there is only mystery, only wonder, only questions, and that's okay. That's more than okay. It's beautiful. The universe inviting us to seek, to search, to wonder, never quite giving answers, but always offering more questions, deeper, more profound. You cannot hear your heartbeat anymore, cannot feel your breath. You are beyond sensation, beyond awareness, beyond everything, just being pure, simple, perfect being. Dark matter, the invisible architecture of everything, holding galaxies together, shaping the cosmos, bending space, bending time, and yet unseen, unknown, a ghost in the machine, a whisper in the dark, a question without an answer. Yet the scientists will keep watching, will keep listening, will keep searching with patience, with dedication, or with hope that someday the darkness will speak, will reveal its secrets, will show us what it is, why it's here, how it works. But until then, we wait, we wonder, we drift through the mystery together. And we'll keep drifting, floating together through the mysteries. 100 dark matter mysteries, looping softly, endlessly, through the night. Tonight we drift through the invisible universe, the dark ocean that holds everything in its gentle, unseen, eternal embrace. The universe keeps turning, held fast by dark matter's unseen hand, and we'll keep drifting, floating together through the mysteries, and we'll keep drifting, floating together through the mysteries. 100 dark matter mysteries, looping softly, endlessly, through the night.